The Snowflake Query Profile is a visual tool within the Snowflake data platform used to analyze and optimize query performance. It breaks down query execution into a tree-like structure, revealing how data flows through different operations. Think of it as a detailed map of your query's journey, highlighting potential bottlenecks and areas for improvement. This tool is crucial for identifying inefficiencies and reducing compute costs. As of 2025, Snowflake has integrated AI-driven insights to automatically suggest optimizations. The query profile in Snowflake is easily accessible through the web interface or APIs. After executing a query, you can view its profile to understand the execution details. In Snowsight, navigate to the Query History section. Select any completed query from the list to open its detailed profile. The profile displays a graphical tree showing the query's execution plan. Each node represents an operation, connected by lines that show data flow. Navigation features include zooming in and out, panning across the diagram, and clicking nodes to drill down into detailed metrics. The tree flows from source tables at the bottom to the final result at the top. Color coding uses green for efficient operations, yellow for moderate, and red for potential issues. These navigation tools make it easy to explore and understand query performance in Snowflake. The Snowflake Query Profile represents query execution as a series of operators, each performing a specific task. Common operators include table scan for reading data, join for combining tables, aggregate for calculations, sort for ordering, and filter for selections. Each operator displays key metrics like execution time, rows processed, and bytes scanned. The profile forms a tree structure, with the result at the top and data sources at the bottom. Read from bottom to top to follow data flow, and top to bottom to understand aggregations. For example, join operators combine data from multiple tables, as shown in this detailed diagram. This execution plan example illustrates how operators work together with their metrics. Understanding these operators helps identify bottlenecks, like slow joins or excessive scanning. Several issues commonly appear as bottlenecks in query profiles. A table scan with high bytes scanned might indicate missing micropartitions or inefficient filters. Excessive spillover often points to insufficient memory allocation. Imbalances, where one operator consumes a disproportionate amount of the query time, signal a potential problem. Cartesian joins, where every row from one table is joined with every row from another, are notorious performance killers, easily identified by the massive row counts in the join operator. Once bottlenecks are identified in the query profile, apply optimization techniques. Start with adding where clauses to prune unnecessary data during table scans, reducing the bytes scanned and improving efficiency. Use cluster by to improve data partitioning, organizing data on key columns for faster lookups and reduced scan times. Implement materialized views to cache results of frequently executed queries, significantly speeding up repeated access. Convert subqueries to common table expressions for better readability and performance improvements in complex queries. Leverage Snowflake's AI-powered recommendations for automatic suggestions on query rewrites and alternative join algorithms. Let's examine real-world examples that demonstrate the power of Snowflake Query Profile analysis. An e-commerce company struggled with a daily sales report running 10 times slower than expected. The profile revealed a full table scan on a 5 terabyte fact table caused by a missing clustering key on the date column. Before optimization, the query took 20 minutes to execute. By identifying this bottleneck through the profile, the team added a clustering key, dramatically improving performance. This optimization reduced execution time from 20 minutes to just 2 minutes, achieving a 90% performance improvement and significant cost savings. In another example, a financial firm optimized a complex risk calculation query involving joins across hundreds of tables. The profile showed excessive spillover to disk due to memory-intensive sort operations. Switching to approximate aggregations eliminated this bottleneck. This change cut the query runtime by 70% without significant loss of accuracy. These case studies illustrate how systematic profile analysis can uncover hidden inefficiencies and deliver substantial performance improvements in real production environments. The future of Snowflake query profiles is trending toward increased automation and AI integration. By 2025, Profiles incorporate ML models to predict query performance and detect anomalies. Profiles are also adapting to Snowflake's serverless and multi-cloud environments. Experts predict fully autonomous query optimization by 2026 to 2027, where profiles trigger self-healing actions. Snowflake's chief architect states that query profiles are evolving into AI assistants that turn diagnostics into prescriptive actions. Stay tuned for exciting developments in the realm of data-driven query optimization.